Okay, welcome back from the break. Now we are going to see it, the way we do supervised learning in Python. Actually, if we think about supervised learning, there is two topics in supervised learning, which is classification and regression. In classification, there is discrete class. For example, we want to classify between image of dog and cat. There is a dog and cat, right? There is no semi-dog, semi-cat. No such thing like that. In that case, it is classification. It can be more than two class. In two class, if we have two class, we call it binary classification. Normally, it will be like the class that we focus on and the class that we don't care about it. For example, for cancer, the record patient record may be labeled as have tumor or doesn't have it. The one who have it, we call it a positive class, and the one who don't have it, we call it in negative class. We just want to classify which class this data point should belong to. For example, in this case, we want to classify which of these records should belong to Virginica, which of these records should belong to Setosa, something like this. However, most of the, well, it's not most of the, but scikit-learn, the scikit-learn itself, it decides to do binary classification. In the case that we have more than one classes, more than two classes, it will become multi-class classification. It will be a little bit harder, but not that hard. In this case, I will demonstrate you the way to do binary classification first. Now in IRIS dataset, if you got this notebook, when you run the first one, it will load the dataset here, iris data.csv, into data frame. Well, maybe you already forgot about how to do that. In this case, in my Google Drive, I put my dataset into a folder called dataset2, like this one. And this dataset is some kind like in Excel, something like that. But the format is actually .csv, not XLSX, which is Excel format. In this case, there is data here in form of table. So now, from this data, we read it into Python. This one. Oh, okay, let me remove this. Okay. So after we read this thing, we get something we call data frame. And instead of classify 3 classes here, which is Setosa, Virginica, versicolor, it will be too hard. I just want to classify these species belong to Setosa or not. In this case, if it is Setosa, it will be a positive class. If it not, it will be a negative class. To represent it, to represent this class belong to which one? We can use a number to do that. In the first case, we have to check it first. This one is the species is equal to Setosa or not. This one. If you run this line, it will return false, true, and false like this one. If the string on this column is equal to Setosa, like this one, it will be true. If it's not, it will be false, similar to this one. However, we want it to be a number, a number 1 or 0 or something like this one. We can do that by cast the data type using as type and turn it into integer, like this one. If we run this line now, it will become 0 and 1. 0 mean negative class, 1 mean positive class. And I assign it back to a new column called label. Now we have feature and also label here. Do you remember what we have to do next from Mathematica? We have to split this data set into 2 sets, which is training set and testing set. In Python, we can use a function from scikit-learn. This function will do the work for you. You just have to put the X, which is a feature, and Y, which is a label, and you have to specify a testing ratio, which in this case, I want to make it 25% of overall data set to be a testing set. And also this one is important. You have to put the random state, because when this function split this data set, instead of it's cut at 25% here at the bottom as a testing set, it will randomize the row first. So to make sure that the data here mix well together, let's imagine that some kind of data set that contain maybe 50 rows of setosa at first, then 50 rows of virginica at the middle, and so on. If we don't mix it before we split train test, it will not be good, right? So in this case, we have to mix it first. Anyway, the function will do that for you. But it is a random process. So if you want to do this at the first time and repeat this code the second time and the third time, you want it to be the same. In that case, you have to put random state so that your code, your experiment will be redoable. After that, after we split, we put all parameters here. You will get training set, which is x, and we call the feature as x. And y is label. You will get x train, x test, and the label in train and test. If we compare this one with Mathematica, the number of train is 112, right? And test is 38. 112 and 38. Compare this one to Mathematica. Yes, we do have the same number, yeah. This is 112 and 38. Okay. Well, I think it's okay now. Now, next, we have to train our model. But there is so many model in scikit-learn, or maybe in this world. There is logistic regression, decision tree, neural network, or so on. There is so many things. In this case, I will pick 3 of them. Show you how we train each of them. But in real life, you may have to pick more than the 3. You may put naive Bayes, anything in this list. You can search for that and try it. In logistic regression, we don't have to put anything, no parameter. Actually, it has parameter, but you can omit it. I think it's okay for now. For decision tree, you may have to put random state. Well, I don't think there is no randomize here, but I suggest you to put, if there is, you have to put random state. Always do that. And for the last one is multi-layer perceptron, or you can call it neural network. If you may have to put hidden layer. Neural network will be something like a layer of neuron, right? For example, we start with input layer, and there is hidden layer here. And then is output layer. In this case, there will be one output. So the number from input layer will be feed into hidden layer, and then output from hidden layer will be feed into output layer. Anyway, in this case, you have to specify the size of hidden layer. How many nodes you want it to be. In this case, the data set here, there are 4 dimensions. So the default of this function is, I think it's 100 nodes. I think it's too much, so I reduce it to 4 nodes here. If you want it to be 2 layer, you can put it another number like this one. You want it to be 4 at first and 2 at the second layer here. So now the hidden layer will be 2 layer. The first one is 4, the second one is 2, and then output layer. It's do the rest for you. You don't have to worry about how it works, how to train it, the linkage between each layer. You don't have to worry about that one. You just put the number here. I will remain 4 and run it. Anyway, I guess maybe we don't talk about logistic regression yet. So I want to show you a little bit how it works. In logistic regression, I want to go back to linear regression. I think you guys know linear regression already, right? Let me revise that for you. In linear regression, we have a data point like this one. For example, this figure here. The dot is data point. X is a feature. We have, in this case, there is 1 dimension of X, and Y is a label, our target. In this case, there is no red line here at first. We have only dot data. To do regression, we want to find the trend of the data. So we create a line that best fit with this data. After we have this line, let's say if we want to know if the X is 0.6, what Y be? We can project 0.6 to this line and then project it to Y. So we will know that if the X equal to 0.6, Y will be something like 4.3 or 0.4 or something like this one. This line is actually a linear equation. If we talk about linear equation, it consists of Y equal to maybe some kind of coefficient here, W and X, right? And maybe plus intercept. W is actually a coefficient, or maybe you can call it a slope or weight. I will call it a weight. And B, maybe B is a intercept, right? Or you can call it bias. In this case, we have to find W and B. Anyway, you can solve it. It's not that hard in one dimension or even two dimensions. It's not that hard. But in scikit-learn, it do that for you. In this case, we want to do classification. Now, y here will not be in continuous. It will be only in 0 or 1. If you use linear regression and the x, for example, x is in here, if you project it to this line, it will be more than 0. In this case, it's okay. But if x is here, in this value, let me call it x2, this one is x1. If we project it here, it will be maybe 0.3. I think this one is not that bad, because maybe we can say that if the value is lesser than 0.5, that data point will belong to a negative, the negative class. If it's greater than 0.5, it will belong to positive class. You can say that, but the number will not be usable. Let's imagine that we have x here, x3 is here, the value is here, and if we project the number to this line, it will be greater than 1. Well, you may not get it 1 yet. Let's say that I want it to be not greater than 1. If I can find some function that apply this line on the left here to be the one on the right here, I think it would be better, because as you can see, this one, it will not be greater than 1. It will closer to number 1 here, but not greater than 1. Anything else about it? It is when you have the value range from 0 to 1, you can use it as probability of that data point. The probability of that data point belong to positive class or belonging to a negative class. You can use that one. In this case, it will be better than the first one. And the way to transform the line from the left to the line at the right here, we can use something called logistic function. If you search the word logistic function, it will look like this curve. And even here, there is a formula for you. This equation is actually a logistic function. The x will be put here. x0, as you can see it here, is a midpoint. This one is maximum value. But in our case, it will be number 1. It will be 1. and K is growth rate. So this is logistic regression. We can use that for doing classification. That is strange, right? Ironically, the name of this one is logistic regression, but I'm not sure, but I don't think we are going to use that to do regression. We mostly use it for classification. So please beware about this one. I have seen the question about this one on exam paper before. Anyway, let me show you something more about logistic regression. Well, thanks to Dr. Pumchai, he provides us this demonstration. In this demonstration, you can try to tweak the value of line here to classify between the red class here and the blue class here. You can use this button. Anyway, in this case, the line is different from what I told you before. The line I told you should be in this direction. However, you will be confused because this data set is actually in 2 dimensions. We have x1 and x2. This one is x1 and x2 is here. Y is actually in z axis here. This line is called decision boundary, which is a boundary that it will decide which data point will be in the red class, which one will be in the blue class. This boundary, if this one is located above of this line, it will become blue class or positive class. If that one is under this line, it will be a negative class, like this one. All of this one is in negative class, but the color is actually the actual class that it should belong to. So in this case, you can see that if we predict this one as blue line, it will be incorrect, right? So we have to find the base split of the data set. So you can tweak that with this one. What you can do is you can control this fixed point here, the big red dot here, and the below one. This line will be drawn from the first point to the second point. But you cannot do it perfectly because the data set here is some part of them is mixed together. You may have to sacrifice some of them. And what happens if I put this line here? Well, As you can see, the red dot here will be classified as, all of them will be classified as in red class, as well as blue dot here. In that case, this model can almost perfectly classify the red dot. However, for blue dot, it also classify this blue dot into red class. If you look at this gate, the arrow point to near zero. This one is accuracy of red class, and the blue one is point to accuracy of the blue class. And you can see for red class, it is quite actually it's not accuracy. It's like an error. And you can see we can predict all of them in red class. We can almost perfectly predict all of them. So the error is quite low in red class, but we do that worse in blue class. The error in blue class is high now. If I adjust it a little bit, like this one, you can see it reduced the error of the blue class. And this tau here is actually a parameter to adjust the curveness of logistic function. If I reduce it, it will become a flat plane like this one. If I increasing it, it will become an S curve. And if we put it at maximum, it will become a cliff. Well, as I told you, this function is some kind of scoring. It's like a probability. So maybe the one that located near decision boundary here, it may have a 50-50 chance to be in positive class or negative class. So you should find this parameter that's suitable for your data set. However, luckily you don't have to do that by yourself. The library will do that for you. You just have to create logistic regression like this one. And then after you create each of them, you specify the parameter here. You can now train it. Anyway, before you train the model, you have to be aware. You have to be aware that which algorithm you must scale it first. If you go back to the last time, we do clustering, I also mentioned that we have to scale our data set first, right? We can use min-max scale like this one, which is the x here minus min value divided by max subtract with min value like this one. The length of the data will be in 0 to 1, like this. And then, however, in this time, we don't have to write a code like this one. Instead of this one, we can import this class from sklearn, scikit-learn here, like this one. You just create a new class and fit it with our dataset and then transform it. And then the resultant data here, you can put it into our model. You don't have to worry about anything else. In logistic regression, you just do this. The name of variable dot fit, and you put the x and y here. It will train for you. I will show you. Oh, maybe I have to rerun. Okay, run this one and this one and this one, and then this one. Okay, now it's trained for you. In Python, you can in Colab or even in Jupyter Notebook, you can add this magic command here. It will measure the time to run all of this operation of this code. Now the time is this one, 20 milliseconds, which is quite fast. Well, maybe let's go back to the Mathematica. If you train it, this one, it will consume 6. I'm not sure what unit is. I think maybe 6 milliseconds, or maybe 6 seconds. I think it's 6 seconds because it will train more than one model and have to find the best fit for you. So it might have to consume more time than in Python. What about decision tree and MLP? We can use the same way to train it. Just variable name and dot fit, like this one. After you fit it, you can use this object to do prediction. Anyway, for decision tree, you don't have to scale the data first. You don't have to worry about that. But I want it to be simpler. So I will only put the scale data into every model. Okay, at the first step, we have done the first step already to train models. Now we have to evaluate models. In this step, as you have seen before in Mathematica, we will have to compute the accuracy and find the confusion matrix and then plot this graph. In Python, you may have to do some work. It's not that simple. In this case, I already write some codes. First, in this function, when you pass model and the data set here, it will use the model to predict something for us, which it become y predict. And then we can compare the result from y train and y predict using this function. You can import the scikit-learn, import matrix, and you can put the matrix dot classification report. It will provide you some result, right? This one, I will show you. This one. Oh, okay. This one is the result from this function. In this function, it will show you a precision recall, well, accuracy, and so on. You can learn about that one in the Wikipedia. What is precision and recall? Anyway, I will briefly tell you. In confusion matrix, as you have seen that before, we are going to put the number of the one it predict correctly and the one it predict incorrectly into each group. For example, this one is it is predict as positive, right? And the true label, this one is a positive. In this case, all of them, the model can predict it correctly. 40 of them is here. For accuracy, it must be this number, 40, divided by the number of all data points, which is 40 plus 72, like this one. This one is accuracy. For recall, if you go to this one, it will be something that's similar to what I've shown you before. The X here is predict condition, and this is actual condition. If it is positive and you predict positive, it's called true positive. If it's negative and you predict it's negative, it will be called true negative. The rest will be false positive, false negative. False positive means you predict it positive, but it is not. This one is false positive, and you can see the alphabet here, right? TP is true positive. FP is false positive. If you go to the table here, this panel, and you search for precision here, you will see the formula. It's a true positive divided by the one that getting predict as positive plus. And for recall is actually the one that is true positive divided by the one that actually up in positive class. This one is precision and recall. If you use the function, that particular function, it will show you this. Anyway, and this is This is confusion matrix. In confusion matrix, you can use the function plot confusion matrix, which it forms scikit-learn. You don't have to rewrite that by yourself. You can import it. And you can also plot the RLC curve here. It will do the work for you. I separate the training set and testing set. And also plot the one from logistic regression, decision tree, and multi-layer perceptron. The result will be here. Yeah, it looks good. All of them looks good. Anyway, some of them is not perfect. You can just pick the good one, the perfect one. In this case, the best one. This is how you do things in Python. If you want to do the multi-class classification, you can use this. You can import it. You can use this pipeline, and you just put the model here into this pipeline and use it as like you never do it before. You just fit it and you can predict it. However, if you want to evaluate it, it will be a problem. The first one, if you want to show, if you want it to report performance for you, it's doable. For confusion metric, it's doable. But for ROC, well, you cannot use function anymore. You have to rewrite your own confusion matrix. You cannot use sorry, you have to rewrite your own ROC curve function. You cannot use this one anymore. So I think we may have to stop this class from here. I mean next you will going to present your project. I think you can go home and study this one by yourself. It's regression. It's not that hard. Instead of import the model in this class, for example, this one, decision tree classifier, MLP classifier, instead of import this, you can change your model to this one, decision tree regressor, MLP regressor, and you can do things. So I think this one will be your homework to explore this one, but you don't have to hand on. I mean, hand over this one to me, back to me. Anyway, before we are taking a break, I want to check which of you are not here. If I call your name, please raise your hand. I think some of your friends just went out, but okay, I will check with him. Oh, he's here, right? Okay. And Miss Kushi is not here, right? Not here. Jinjutha not here. Natchanon. Natnisha. Okay, you here. Let me highlight it. You as Nanisha Bunyada. Okay. Panapak. Okay. Pornpicha, not here. Pichayawat, are you here? Not. Avarin, not here. Kevin, okay. Tuta, no. Martin, oh, okay, it's you. Yeah. Oh, she dropped her clothes. Emmanuel, okay, you. Emily, okay. And Sulapas, you. And the last one is you, right? Okay. So how many? 6, 7, 8. Okay. I think maybe each of you may have 10 minutes. I no, not 10 minutes. Maybe let it be 6 minutes, 8 minutes, something like this. One present your project. I don't think maybe you can join this Zoom section. So you don't have to come here. You can just be over there and present your work, share your screen. And maybe if you want to use microphone, you can take that one. Okay, let's take maybe 5-minute breaks and go back again. Oh, you don't have Zoom? Your TA will post that in the group. Okay.